Hello everyone. In a previous lesson, we had understand the first type of database, which is OLTP, Online Transactional Processing Database or Relational Database. Now we need to understand the different other types of databases. We have data warehouses, we have Online Analytical Processing Database, OLAP, we have column-oriented databases, NoSQL databases, and ad hoc, and we have hierarchical databases. SQL graph is not a database type. It's just an additional topic which we need to add it to this lesson. So for now, we need just to understand all these others, at least to have an idea to understand them in case I tell you we have a database and the type of database on that server is Hadoop. How you gonna make a backup for it and restore? And is there any difference with another SQL server when there is a database of type column-oriented databases, or we have this column-oriented databases? What kind of programming language we might use to access to it? These kind of technical issues. Now, there is always a line between your work as a system admin or as a database developer. And you are the one who's going to draw that line, and you know exactly how far you need to learn with the databases, because otherwise you might find yourself one day a developer of database and you totally leave the system admin job. It's up to you anyway. Okay, let us now start to see what type of databases do we have. So we start first with the database for the warehouse. It contains very large databases that typically contains historical data instead of current transactional data. For example, in organization you might use an OLTP database to process and store a transaction for the current month. And also you can create a separate data warehouse to store a transaction from previous months and years. And by this, you are free to create any report to know exactly, especially with analytics, if the sale is going up or down, and according to that, you can provide the right reports for the higher management to make decisions. Now, the downside of such design, when you read data back from the database, you have to locate the required data in multiple tables and correlate it so that it all matches up. And the query engine component of the database management studio does this work for you. It is a relatively time-consuming process. Here in this diagram, you can assume you have all these small databases. They are transactional, OLTP, and they are for branch offices. And during the month, by the end of each month, you are going to load the bulk of data to the warehouse database, and then you can create the right reports for the sales on all these branch offices. The main problem of this design is the amount of data which is in there. Once you try to load that bulk data, you need to make sure the data is going to be saved in the right tables in the warehouse, and there is no conflict and no overwritten, no problems, etc. The data in warehouse can come from many different sources, including spreadsheets and also the CRM, the customer relationship management, in addition to ETL systems, extract, transform, and load system. And the main source is, of course, the OLTP, which is our relational databases. And usually the design of warehouse is a star design, where all the databases need to load the data directly to the center warehouse. Now, the next type of database types is online analytical processing databases. With this one, data warehouse serves as a data source for OLAP. So this warehouse now is going to provide data for OLAP for analytical processing, and the major goal for this one is to provide information for the higher management, and according to that, higher management can make a right decision. OLAP systems use pre-aggregated data and specialized storage for fast data analysis with very large data set. Also, the database figure which is going to be used is known as multidimensional databases. And with this one, we create a structure called a cube to store measures with data, aggregated data, numerical values, etc. Currently, OLTP, data warehouse, and finally OLAP are the major topics for databases. But in addition to that, we have some other databases types we need to discuss. They are not that much common, but you might have one of them from time to time. Now the first one is hierarchical database and the other one is NoSQL database. And the structure of hierarchical database is to store data in a different way to relational database. Instead of arranging data as a set of related non-hierarchical entities, with hierarchical database, it's arrange data in a multi-level structure. As we see in this diagram, we have the root, and the root has child, the child has child, and so on. Now, an example of such design is the Windows file directory itself, or Linux. Now, this design is good and fast when we have one-to-many relationships. For example, the root has many relations to child, child has many relations to child. But if you have many-to-many relationships, then it's better not to use such design, because in that case, relational database is faster and it can be used for such technique to save bulk of data with many relations. The next one is the column-oriented design or databases. With this one, as we see, the relational table, which is being represented in this table, it can be described once you want to use a column-oriented storage like this. So here let us take a look. For Dominic, for example, the number is 1. For Darren, the number is 2. Linda, number 3. Which means the main ID number for each one of these users. And now we need to link that with some other information, like for Darren and Linda, both of them, the last name is Martin. So Martin is being assigned to number 2 and 3. Now Jewel is being assigned to number 4. USA, as we see here in this, the country, is being assigned to 1, 2, and 3. And UK is being assigned to number 4. So this is how you can use a column-oriented storage database. Next database type is NoSQL database. The main idea behind it is to be used to save a large amount of data, especially when you have videos and these such big files with the huge size it has. Now, the main difference between the relational database, SQL, and NoSQL database, non-relational, is because of the type of data. A relational database, a single byte is important. So that's why the system is going to use a technique or a procedure. We called it ACID, which is atomicity, consistency, isolation, and durability. With that one, you make sure now each byte is integrated and the data is valid. Especially if we are talking about a bank system, you cannot make any mistake with even a single byte of data. With such a database, NoSQL database, I need it maybe to store movies. So if I lose some pixels or even some bytes in the movie, it is not going to disturb the content of the movie itself. I might get some green pixels or squares on the screen through the browsing of the movie, but in general it's not going to disturb anything or create any problem. So that's why it's good to use it for such kind of data. But once we dealing with the real systems, with bank systems, then definitely we cannot use NoSQL databases. The next one is Hadoop, which is a big data technology that offers massive processing power for processing very large data loads. It can work well with semi-structured like XML files. It can be used to save data, and also XML can be used to transfer data from, as an example, Oracle database to SQL database. The data can be saved first, migrated from Oracle to XML files, and then after that is going to be imported or migrated again from XML files to SQL databases. It's good with read-only files, not read-write files, and also is good even with the processing of movies, which is unstructured at all, not even semi-structured. Now, SQL Server, starting with SQL Server 2016, we have now a new feature, we call it Polybase, which integrates SQL Server with Hadoop environments. So by this, you can get the benefit of Hadoop in SQL Server when you try to process a semi-structure like XML or no structure like videos files. By this, we're done with the database types, but we still have SQL Graph. Now, SQL Graph, it was presented first in 2017, and currently, of course, also is available in 2019. This is a graph database, allow complex relationship to be modeled and simplified the analysis of many-to-many relationship. The SQL Graph enables the graph nodes and edge to be stored and queried in SQL Server. This is a bit advanced for us of what we try to do now, but we just have an idea about it to know what is being used for. And by this, we had covered all different type of databases. And also we have a basic understand for all of these terms and technologies. That's what we have in this video. In the next video, we need to talk a bit about data analysis. Thanks for watching.